So now we will cover 5.5, which deals with identifying and writing conic sections. Here are all the standard form equations that you will have to identify each type of conic section, your equation for circles, parabolas, ellipses, and hyperbolas. So what we want to look at is being able to identify the type of conic section from the given conic form equation and then rewriting it in standard form and identifying the important information. So the first example says to write in standard form and then state the conic section including the direction and center and vertex. So remember our steps that we're supposed to take, but before we get into doing any of this, we want to first identify what type of conic section this is. And looking at this equation, we can see that this is going to be a parabola because it only has one variable that is squared. That's the y squared. So now that we know it's a parabola, what we want to do is we want to rewrite it in standard form. So we're going to group everything together, group our y's together, and move everything else over to the other side. So now we'll factor out this 3. And we'll perform our completing the square portion. So 3y plus 4 squared equals 4 squared times 3 plus 16 times 3. So that in turn gives us 3y plus 4 squared equals negative x. 16 times 3 is 48. 48 plus negative 50 gives me minus 2. So now we'll put everything back in the proper order. So we'll move this 2 over. And now we want that x to be positive, so we'll just change the sign of everything on the other side. Or multiply by -1 or divide by -1, whichever one you are familiar with. So now this gives us a parabola, and this parabola is going to be a horizontal because the y is squared in this equation. Not only is it going to be horizontal, but our vertex is going to lie at -2, -4. And that's how you identify this information from the standard form equation. Remember now that it is a y squared parabola, your k is on the inside as the 4 and your h is on the outside as the -2. So the next one, we'll look at the next problem. Notice that you have an x squared and a y squared. So that means it has to be an ellipse or a hyperbola or a circle. Being that these two numbers are different, it cannot be a circle. But since it's positive between the two, they're both the same sign, it's going to be an ellipse. So again, we'll perform our completing the square operation to write this in standard form. We'll group our x's together. And move the constant to the other side. So now we're going to group our, factor out the 16, factor out the 9, alright, once you've done that, now you can complete the square portion. Was 47 plus 1 squared times 16, that's just 16, plus 3 squared, which is 9 times 9, is 81. So combine all that together. That gives you 144. So we'll divide both sides by 144. And that gives me x plus 1 squared over 9 plus y minus 3 squared over 16 equals 1. Now, because the 16, the larger number, is under the y, this is going to be a vertical ellipse with my center point at -1, 3. So now we'll look at the next one. The next one is similar to the one that we just did with the ellipse, but the only difference here is now we have one that is a different sign. Since that is the case, we can see that this is going to be a hyperbola. Alright, so now again we'll group our x's together and group our y's together. Since there is no other x term, we'll just leave the 16x squared by itself. Alright, so we'll factor out the negative 25. So y squared plus 2y equals 425. So 16x squared, complete the square operation. 425 plus 25, and that's going to give you, or negative 25 actually, and that's going to give you 400. So we'll divide both sides by 400. And that gives me x squared over 25 minus y plus 1 squared over 16 equals 1. And our center point is going to be at 0, negative 1. And what direction would this hyperbola be? This is going to be a horizontal one. Alright, and for the final one on this page, we see that both of them have the same number in front of x squared and y squared, and they're both the same sign, so this has to be a circle. So again, I'm completing the square operation, 4x squared minus 20x plus 4y squared plus 24y equals negative 45. So factor out the 4. Complete the square. Okay, so that's going to be, we're going to add our values to the other side, so that's going to be plus 25, 3 squared, 9 to 4, plus 36. And that will remain us with 16. So now we will divide everything by 4 to get rid of these coefficients. So our center is going to be at 5 over 2, negative 3, and the radius is 2. So that's how you identify those conic sections from the given equations, and you guys should know how to write them in standard form. Alright, a couple of things that I want you guys to remember when doing these problems on this section. Write an equation for the given conic section with the provided information. Here you are just simply working backwards from what you do have to find the equations. So for this one, you have the ends of the diameter. Well, this has to be a circle. If you have the ends of diameter, you need the midpoint, which is the center. So the formula for midpoint, x1 plus x2 over 2, y1 plus y2 over 2. And that's your formula for midpoint. So if you find that, you can get the center. Now you also need the radius. So you can find the distance between these two using the distance formula. Once you find that, divide it by 2, and that equals the radius. And once you find that, you can write your equation for the given circle. For example, B, you have a vertex and an axis of symmetry. So we know this has to be a parabola. So if we know that it's a parabola, we can use the given information to identify the equation. Well, you were given the LR, and we know the LR, 6 has to equal 1 over A, the absolute value of that. Well, if that's the case, A equals 1 over 6, but it's going to be negative 1 over 6 because A is less than 0. You already have your vertex, and you have your axis of symmetry, x equals negative 7. So that tells you the direction of the parabola. And that lets me know this one's going to be vertical. So you can use that given information to write your equation. Endpoints of the major axis and the minor axis. We know which one gives us a major axis and a minor axis. And we know that has to be an ellipse. Ellipse has a major axis and a minor axis. So if we do know that, we need the length because the major axis is 2A and the minor axis is 2B. So you can identify A and B from that given information. So you would need to find the distance between the major axis and the distance between the minor axis to find out what A and B are. Once you know what A and B are, you can find the midpoint between the two, and that gives you your center point. Gives you the center point, and then you can write your equation from that. Alright, for example D, the vertices points are negative 1, 0, negative 1, negative 6, where the foci points are negative 1, negative 3, plus or minus radical 13. Well, for this one, it has to be a hyperbola. Alright, so if you find your center point will come from the midpoint of your vertices, and the foci points, you can identify what C is from the foci points. And you can get A from the vertices. And if I have A and B, then I can find out what C is using that Pythagorean relationship. And then I can write the equation of this hyperbola. For example, E, you have a vertex and a focus point. We know this has to be a parabola. So you can use that given information. Remember that we get our focus. We get the focus from 1 over 4A. So using that information, you can identify what A is, and you have your vertex, and that will give you the equation of your parabola. For F, the center point is at 6, negative 7, and the tangent to the line x equals 1. So I've given you a diagram and the equation of this one already. So at x equals 1, that's that dotted line that you see. And so if the circle is tangent to that line, and the center is at 6, negative 7, the distance from the center point to that line is going to be 5 units. So the radius has to be 5. And so we already wrote the equation of that circle for you. G, the vertice points are 6, negative 6, and negative 2, negative 6, where the perimeter of the central triangle is 36. So we know this has to be a hyperbola because of that central rectangle. Sorry, not a triangle, the central rectangle. So remember, if I was to graph that, I have one vertex here, and the other one would be here. So that means it's going to look something like this. But remember, I have that central rectangle on the inside, and it has a perimeter of 6 units. Well, this distance has to be 8 units. Has a perimeter of 36, but this distance has to be 8. So you need to identify what these other two distances are, find the center point, and you can find your A and B values that way. And lastly, you have a center point, a major axis, and the foci points. So this is going to be a ellipse. So your foci points give you the C value. Your major axis gives you your A value. And so you can find your B value using that Pythagorean relationship. And then you can write the equation of the ellipse. So I've given you all the information that you need to write the answers for these problems. And I will post the answer key to each one of these in the examples. So just go through some of this information and try to solve all of these problems. And that's the conclusion of 5.5.